Hello everybody. So, let me adjust the audio, wait. Okay, hello everyone. Today we will be slicing three-dimensional figures and seeing if we slice a three-dimensional figure with a plane, what is the maximum number of sides we can get within that slice. So, really quickly, let me just show you what I have here. I have a subdivided plane right here. And this plane will be able to cut this cube however we want. Okay. And then we can view the cut. So we could cut it. And the way I'm doing that is I have a plane, and I could technically set this to wire and then just draw edges. I'm drawing the wireframe of this object, and to give it a little bit more thickness, I added a solidify modifier so that's more visible. And I have a cube hid. I have a cube hid over here. It has a constraint where it copies the location, rotation, and scale of this plane that we're slicing. And basically, this cube that's being sliced has a Boolean modifier, so that whatever part of this cube is contained within this much larger cube that is controlled by this plane will be subtracted off of this cube. And if we hide the giant cube, you can see we have a slice. So let me just undo that rotation and I'll hide the cube. So first of all, by slicing a cube, you'll see that slicing it parallel to the ground plane, the XZ plane, will give us a square. Right, so let's view this from the bottom. So viewing it from the bottom, here I'll view from the front here, with the orthographic projection. If I move this up and down, okay, so there's no perspective in this. If I move this up and down, you'll see that the two-dimensional shape made is a square. If you go above, then it disappears. So that's good. But what if we rotate it? So I'm gonna rotate it by 45 degrees. Now you can see from here, if you slice into this edge, you can see that this shape starts to form. So it's a rectangle because this face right here, you can see that this face is a rectangle and it will stay a rectangle. Just rotate it back by 45 degrees. Now, if we rotate it 90 degrees this way, we'll see that the face it makes as we move it is a square. What happens if we do not... What happens if... Well, we could cut this from the corner, right? That would be a bit more interesting. So let's rotate 45 degrees. And let's move this over here. Okay, if we cut into the corner like this, you'll see that the shape created is a triangle. And that is because if we hide this plane for a second, and we just look at this cube, you can see by bringing the plane on this vertice, and then bringing it backwards a little bit, all we're doing is we're slicing these three edges. By slicing these three edges and creating vertices there, we create a triangle. And that is exactly this triangle right here, because the plane is intersecting those 3 points of that line segment. Now, if we go to the side, if we keep on moving this, first of all, I'm going to give it a different rotation. Okay, so the rotation isn't in 45-degree increments, it's 36.7 degrees, okay? So some random rotation. And I cut it like this, such that 3 points of the cube are sliced off. You can see that there are 5 line segments of the cube that are being intersected by the plane. And these intersections are very important because these intersections are the vertices of the shape created when we slice the plane over the cube. So since we're slicing through 5 line segments now, we're creating 5 vertices cutting through these segments, and therefore get a pentagon. So let's go see the shape that it makes. If we look at this shape now, you can see this is a pentagon. So we've just made pentagon. We've made a pentagonal slice on this cube. So you might be inclined to say that the greatest number of vertices of a polygon that you can create by slicing a cube is a pentagon, 5 sides. But that is incorrect, because if we put this at a perfect 45-degree angle, what is... my dog is barking. Okay, so you can see, if we make the coordinates for the center of this plane 0 degrees, and we make this perfectly 45 degrees here, you can see we get a hexagon. Now, it's not a regular hexagon, but you can see that indeed this is a hexagon. And you can see that's because here, by including exactly half of the cube's vertices, we are able to divide the most number of edges to create the most vertices, therefore giving us a hexagon. And I guess that's it for this video. I hope you found that helpful.